Dr. Kapakal stopped. I feel better, I feel more comfortable to call him Gerardo. It convinces me. So, let me start with an introductory remark. It was 8 years ago, 7 years ago, that I first started we started working together. And while I was spending my sabbatical leave at Rensselaer Polytechnic Institute, Troy, that happens to be the oldest technical university in the United States. It's a university where some stalwarts, or real stalwarts, have worked, like Resnick. Probably have heard of Resnick. Probably people who have studied physics might have read the book by Resnick and Halliday. That's a university where Resnick worked. That also happens to be the university where the first transformer was built. So there are so many firsts as far as RPI is concerned. It's a very old and well-reputed academic institution. So it was that time when, a young researcher, Gerardo, started working with me, and it was a very pleasurable time that we had there, having a lot of discussions, a lot of new things to think about, how to go about modeling some of these things. Because the technology was not advanced as it is today at that time, it was 7 years ago. So I was just recollecting some of those things when Gerardo was talking to you. But now I am not going to talk about the conventional heat pipe to you. Starting from that point, I will be focusing more on a spin-off or a later addition into the family of heat pipes called the micro heat pipes. The micro heat pipes, as the name itself indicates, are small. They are not large. So if you want to have a large amount of heat to be handled by micro heat pipes, the option may be to go for a number of micro heat pipes. Maybe 109 micro heat pipes or 1000 micro heat pipes. So micro heat pipe is a small device, but there are some interesting features also, because some of the difficulties associated with the conventional heat pipe can be overcome by using this special design. I'll start with some of the things and explain how it works, etc. But the working principle is not that far away from that of a heat pipe, except that in micro heat pipes you don't find a big structure. You might have by now been clear about how the heat pipe works and what are the components of the heat pipe, like the metallic body, the wick, and the vapor core. And micro heat pipe is a device in which I don't have a wick. But not like a thermosiphon, it's not gravity fed or anything. I don't have a per se wick in it, which is defined by our definition of the wick. But I have a certain structure inside, a certain particular formation inside, which will act as the wick. So this design has certain advantages because of this. The first advantage is being the fact that we can miniaturize the system. So when I later started thinking about microscale heat transfer, going ahead to nanoscale heat transfer and the application of nanotechnology, etc., I was fascinated by this particular idea so that I could work further with that. In fact, right at that time, 7 or 8 years ago, when these concepts came forward, then itself I had started with again our guru, as we call Professor G.P. Peterson. From his taking clues from his ideas, we had started working on this particular concept. And then later also I could work forward to certain designs of micro heat pipes. I'll come to some of these things very quickly because I know that you are tired through bombardment right from the beginning on heat pipes. But Dr. John has allowed me to talk for about 45 minutes. So I work for these two institutions.